Hi, this is Ms. Cho with operations of complex numbers. If you recall, complex numbers takes the form a plus bi with a real part and an imaginary part. So this is one complex number. Let's say you had another one, c plus di. Like real numbers, you can do operations with complex numbers. You can add, subtract, multiply, divide. Let's take a look at how. Multiplication works the exact same way as multiplying binomials, so you can either distribute or you can multiply using the box method, whatever you prefer. I'm just going to distribute. My first term is negative 2 times 5. My second term is negative 2 times negative 7i. My third term is 3i times 5. And my fourth term is 3i times negative 7i. When I multiply all that out, I have negative 10 plus 14i plus 15i minus 21i squared. Remember that I squared is actually negative 1, so this is negative 21 times negative 1, which is positive 21. My real parts are negative 10 and positive 21, so those go together, and then my imaginary parts are 14i plus 15i. I'll rewrite this so that my real terms are together and my imaginary terms are together. And when I combine my like terms, I have a positive 11 plus a 29i. I'll do the exact same thing for my second example. My first term is negative 4 root 3 times 2. My second term is negative 4 root 3 times 5i. My third term is negative I times 2. And then my fourth term is negative I times 5i. When I multiply all this out, my first term is negative 8 root 3. My second term is negative 20i root 3. My third term is negative 2i. And my fourth term is negative 5i squared. But remember, I squared is negative 1, so this is negative 5 times negative 1, which is positive 5. I'm going to rewrite this so that my reals are together and my imaginaries are together. Since my first term can't be simplified anymore, I'm just going to recopy exactly as is, and then this whole thing is my a. Then the second part, my imaginary part, I'm going to actually factor out a negative I, and then my inside becomes 20 root 3 plus 2. This is my b. The bottom line is that you're going to multiply complex numbers like you multiply binomials, and then remember that I squared is equal to negative 1, so your I squared term is actually real. Let's take a look at division. Division works a little differently. The main thing you need to know about dividing complex numbers is that you're not supposed to have complex numbers in your denominator. It's like walking around with toilet paper on your shoe. It's not technically wrong, but it's just embarrassing. The way that we get rid of a complex number in the denominator is to multiply both the numerator and the denominator by the conjugate of the denominator. The conjugate of a complex number is another complex number with the same numbers but opposite sign. So the conjugate of 5 minus 7i is 5 plus 7i, and then we're going to multiply both the numerator and the denominator to keep the fraction equal. When I multiply this out, my first term is negative 2 times 5 minus 2 times 7i plus 3i times 5 plus 3i times 7i. My denominator then is 5 times 5 plus 5 times 7i minus 7i times 5 minus 7i times 7i. When I simplify the top, I get negative 10 minus 14i plus 15i plus 21i squared. And then my bottom is 25 plus 35i minus 35i minus 49i squared. Your I squared is equal to negative 1, so this is the same as positive 21 times negative 1, which is negative 21, and then negative 49I squared is negative 4 times negative 1, which is positive 49. Now I'm going to rewrite my numerator and my denominator so that my real terms are together and my imaginary terms are together. If you notice in my denominator, I have plus 35i and minus 35i, so that actually just cancels. And now my denominator is completely real. Now I'm just going to rewrite this, combining all my like terms, and that will give me my final answer. My final answer is negative 31 plus I over 74. And if I wanted to break that up into an A and B part, this is a negative 31 over 74 plus 1 over 74i. The bottom line is that when you divide complex numbers, you do three things. First, you find the conjugate of the denominator. Then you multiply the numerator and the denominator by that conjugate. Finally, you simplify, combining like terms and using your skills from the other operations.